So in this course, you will learn about advanced driver assistance systems and technologies which are designed to enhance the vehicle safety and improve driver experience. So these are the topics which I'll be going through in this system, going from software, hardware, and the whole idea of the whole systems. So ADAS is basically mainly designed to enhance the vehicle safety and improve the driver experience by various ways. And these systems use many sensors, cameras, radar, lidar, and software to monitor the vehicle's surroundings and provide real-time information for to or automated responses to help prevent accidents and reduce driver workload. So previously, if you see, automotive or car had very basic mechanical components a lot when car was first found and introduced into the market. Then came a bit of electrical components, then electronics, and now it's more software. And it's software is becoming more and advanced, like artificial intelligence and machine learning, and it's becoming more interconnected now. So in this aspect, now we have so many advances in technologies like hardware, in the case like sensors, cameras have become very cheap now, and radar, lidar, and software. So these are all used to prevent accidents and give more information to the driver so that he has a good driving experience and drives safely, and to also reduce accidents. So this is what whole ADAS is about, advanced driver assistance systems. Previously, I have worked like 10-15 years back on lane recognition system for a company called Automotive Distance Control System, and then it was bought by Conti. Then I also worked for Bosch, where I work for pedestrian detection through camera. Because the camera detects the pedestrians, and through image processing, this pedestrian form is detected. These are technologies which were like German car makers were working on like 10-15 years back always, and which you find now in many of the cars in today's world. And advanced driver assistance systems also use radar and lidar. For example, the adaptive cruise control, which uses radar to send signals and detect obstacles, is also used in some of the vehicles. So let's look more deep into this topic. So now let's look at some of the key functions and features of ADAS. And the first one is the adaptive cruise control. Maintains a set speed, automatically adjusting the speed of the vehicle ahead of maintain a safe distance following a distance. So 10-15 years back, like I worked on the same project where the Mercedes project, where we were delivering a system to Mercedes for which was using radar, and radar basically sends out signal. It hits the object and it disperses, and the signal comes back, through which the distance is measured. So basically it maintains a safe distance. So once you set a specific, if you're driving on a highway or a long distance, you can do this, and then once the car will be running over a safe distance, if there's any car coming in between, it will brake. If there's nothing, then it accelerates. So this works mainly with adaptive cruise control. That's what we call basically adaptive cruise control, which adapts according to the cruising will be adapted according to the distance, to maintain a safe distance to avoid any accidents. And this is mainly used for long distance and straight travels. Not for much curved travels will be a problem, because radar is a signal which goes straight in line. So if you are in curved parts, it will go and detect unintended objects. So it's better to use adaptive cruise control in the straight line systems. So lane keeping assistant detects the lane markings, provides steering inputs to keep the vehicle in its lane. So this is done in a variety of ways. One main is the camera. Camera detects the lanes and detects the white markings and the black markings, and this difference in the color is used by the algorithms, image processing algorithms, to detect the gradient variations with which the lane markings are detected. And this, once it's detected, then this goes to the system, and if you cross the lane, then you'll have some sort of vibration or will be a beep or something which keeps the driver within the lane. An automatic emergency braking AEB detects the imminent collisions and applies brakes automatically to prevent or mitigate the impact. So this is about braking systems, which basically does automatic braking depending on if it detects any potential collisions or potential objects. That's what we call automatic emergency braking. Blind spot detection is monitors the vehicles in blind spots and provides alerts to another vehicle if detected. So blind spots are the places where when you sit in the car you can see the front mirrors and the rear, and there are many ways you can see, and now also you have cameras also. So this blind spot is the area in around the car which the driver cannot see, and for that also many of the ADAS systems are there to provide alerts if another vehicle is detected in this blind spot. So as for the some of the components of ADAS, the first thing comes is the sensors and the hardware. So when coming to the sensors, the first thing is cameras, which provides visual data for lane keeping, traffic sign recognition, object detection. Because camera is images, and images provide the maximum information. So many of the companies or many industry leaders determine that. I also did my master thesis in lane camera based lane recognition system. Camera calibration was my topic, and the main research we found was that camera has the maximum amount of data about any circumstances compared to radar or lidar or any other sensors. So therefore camera provides visual data which could be used to detect anything around the car. And radar measures the distance and the speed of the objects, and essential for adaptive cruise control and collision avoidance. So radar is another thing which has been there for a long period of time, and it measures the distance and the speed of the objects, and is used widely in adaptive cruise control and collision avoidance. LIDAR is laser pulses used to create detailed 3D maps of the environment and enhancing object detection and classification. So this is LIDAR is also used for 3D maps and object detection classification. Ultrasonic sensors are also widely used for close range detection, such as parking assistance systems. You use ultrasonic sensors. Infrared sensors aid in night vision systems and detect pedestrians and animals in low light conditions. So as for sensors and hardware, you have to keep in mind cameras, radar, LIDAR, ultrasonic sensors, and infrared sensors. ECUs, electronic control units, process the data from the sensors and execute control commands. And ECUs in ADAS are responsible for tasks such as sensor fusion, decision making, and actuation control. So ECU is a fundamental concept of any automotive or car, and it therefore is an important part also in ADAS. And use for the data which comes from the sensor basically goes to the ECU, and its ECU processes it, and the decision making is done by the ECU. I mean, ECU means it has hardware and software, microcontroller, everything, and then this decision making is given to the actuation control, that is the motor or anything. So this is the basic process. So when it rains, some sensor detects that it rains, then the wiper goes automatically. So the wiper is basically the actuation control, which might have a motor, and the sensor detects the data if the rain is coming, and this data is going to the ECU, which makes the decision, and the actuation, that is the motor, runs. So this is how the ECUs work.